Brian Holyfield here from Gotham Digital Science. Just talking to Brian about this plugin that they've written for IIS7 that does some pretty cool stuff with a combination of sort of WAF-like techniques and blacklisting. He's also going to talk about just IIS7 included, sort of Microsoft included techniques for evading some sort of attack. So we had to talk on offense, and now we've got to talk on defense. So enjoy.
All right, so as Chris said, today we're going to talk about IIS7. The agenda is really just to give a brief overview of IIS7 and sort of a what's new. Then talk about IIS7 integrated mode, which is a new operating mode that IIS7 has that really allows you to do some much more powerful things than you could do before, especially when we talk about applications that are not ASP.NET applications. And then we're going to spend a lot of time talking about IIS7 modules. Specifically, we're going to talk about some modules that come with IIS7 that can sort of be used to do some application security type stuff. We're going to talk about some add-on modules that Microsoft has released since IIS7 came out that are free that you can install on IIS7. And then we're going to talk about how you can build your own custom module. And we've got a case study of a module that we've written that's called SPF that does some, as Chris mentioned, some WAF type stuff at runtime. So we'll kind of run through that as well. So really the first thing to cover is what's new in IIS7, and really the short answer is what's not new in IIS7. Those of you that have played around with IIS7 or that are familiar with IIS6 and 5 and so forth, IIS7 is a complete redesign, complete rewrite of the entire web server top to bottom. It is completely modular, so they have taken a page, so to speak, out of the Apache playbook and made the web server completely modular, where every single piece of functionality corresponds to a module that you can install or uninstall as needed, depending on what you're using the server for. The other thing that they've done is they've done completely away with the whole concept of having an IIS metabase. So those of you familiar with previous versions of IIS know that there was a metabase file that was sort of like a registry-ish type of data store where all the IIS configuration files settings live. That's been done away with, and all of the configuration files are now text-based, and a lot of them are moved straight into a web.config file. So even if an application is not a .NET application, you can stick a web.config file into your web root and fine-tune and tweak out the server settings that way. Another thing they've done, which we're not going to talk about because it's not necessarily related to the topic at hand, but they've introduced support for non-web or non-HTTP services. So when things like Windows Communication Foundation, which allow have built-in binary protocols for web services that are proprietary protocols that Microsoft has come up with, you can actually host those in IIS7 as well. So it really extends beyond just HTTP-based services. So as far as security goes, just like those of you that remember when IIS6 first came out and it had that default sort of lockdown mode compared to IIS5, they've taken it again even further, and pretty much everything is off by default. You can't do anything other than serve static content. Chances are, if you've got an application, unless you actually start enabling some things, it won't run on IIS7. They've also introduced the concept of request filtering. There's a built-in request filtering module, which essentially is like URL scan. That is now built into IIS7. And we'll talk a little bit about the request filtering in a few minutes. So another thing to talk about is the operational modes that you can run IIS7 in. So the new mode, which is called integrated mode, basically exposes the ASP.NET request pipeline to all applications. So those of you familiar with ASP.NET, you had its own, basically ASP.NET has its own request pipeline with several events that you can hook into. Now that pipeline has been unified in IIS7 so that all applications have access to it. Now there is a backwards compatibility mode called compatibility mode that'll allow you to run in the old style without integrated mode just for backwards compatibility. Some applications may break in the new integrated mode. But what it allows you to do is you have this collection of modules. They can be written in either native code or managed code, and those modules apply to all requests, whether or not they're actually .NET application requests or not. So previously, the concept of HTTP modules is not new. It's been around for several years, and .NET developers have used them for years to customize and extend and do some fun stuff with their applications. Well, now you can do the same thing. Any .NET module is basically now equivalent to an ISAPI filter, and it can apply to all requests as well. So what we're going to see here is that the combination of the modular design and the integrated pipeline basically allows us to do some really cool stuff and really it makes the web server very extensible. And that's hopefully what we're going to demonstrate here today. So I mentioned before that every module basically has the ability to hook into one or more of these pipeline events on IIS7. And just to give you an overview of sort of how the pipeline works and sort of how a typical request is processed when it's in integrated mode, you've got the user that essentially will make a request to IIS7, and then the web server is going to then run through all of its different events and figure out which modules, if any, need to hook into the event and hand control over to that module, and then when they're done, it'll take control back. So the different events, there's about 23 events in all, and these, again, are not new. These are pretty much the same events that you've got in the .NET world that you can hook into with your global ASA file. The difference is now the web server modules can hook into these events. And you can really break them up into two categories. You've got your pre-execution events and your post-execution events. And in the middle is where the actual handler will execute, and the request will get processed by, let's say, the PHP DLL if it's a PHP request, or the ASP DLL if it's a classic ASP request. So running through these, I'm not going to go through them, but they execute top to bottom in order. Once the pre-execution events are done, the basically middle, it's not right in the middle, but essentially the middle request is process event, which is where the handler is going to execute. So at that point, control will be sent to the underlying handler, depending on the file type and the request type that's being issued. And then when the request is done, when the handler is done, it's going to then run through all of the post-execution events and give any of these modules the option to continue processing. So the nice thing about this is it allows the module to not only do stuff before the handler executes, but after. And that the main thing that you'd want to do after is things like caching, output parsing, analyzing the response, all that stuff. And again, the list here, just for completeness, they go top to bottom. And then finally, at the end of the pre-send request content event, the content is then sent back to the user. So as we go through this is just an intro, because we're going to see this happen in a minute. But as we go through, there's going to be several examples and demos, and hopefully the demo gods are on my side today and nothing will go wrong. But we're going to be using a classic ASP application to do all of our demos. The reason we chose a classic ASP application is that, like I said before, a lot of the stuff that you can do with these modules you've always been able to do with .NET. The new twist on it is the ability to do this stuff with other things like PHP, classic ASP, etc. So the application that I've selected here for our demo is an application called BattleBlog. It's a free open source blogging package that's written in classic ASP. And the reason it was picked is that it happens to be riddled with several common good security issues that make for great demos. So forced browsing to admin pages, cross-site request forgery, SQL injection, the whole 9 yards. So we'll see that app in a minute, but just so you know, going forward, that's kind of the basis for the sample app and where it came from. And you can download it and Google it and find it online as well. I don't necessarily suggest using it, but certainly it's good to play around with if you want to test for vulnerabilities and so forth. So the first thing I want to talk about is the built-in request filtering module that comes with IIS7. So I mentioned before, this is basically URL scan that they've now just built into the web server. So it's a native module. It's written in C++, and essentially it hooks in, going back to that event pipeline, it hooks into the begin request event. So it's one of the first modules that get executed, and the reason for that, of course, is it's doing some security checks. So we want to catch those as quickly as possible and discard the request if there's anything wrong. So there's nothing really that new here that you didn't have with URL scan, so we're not going to spend too much time on it. But just to sort of reiterate, in case you're not familiar with URL scan, is that it's a really good filter for providing some generic protections. It's now configurable at the application level, whereas before with IIS6 and previous, URL scan just had to be done sort of server-wide. The problem is that from an app security perspective, it's not quite as flexible as we'll need it to be. So it's good for providing generic protections, but if you want to drill down and be granular as far as page level and parameter level validation, or even do things like regular expressions, it really doesn't support any of those. So it doesn't really give us the granularity that we're going to need to do some application level stuff, but it is a good general mechanism, and we'll see here in a minute that when you compare it to some of the other options that we've got, there are some things that it does that aren't very easy to do in your own module. And I've got just the command down here, the appcmd, which is sort of a command line interface for managing IIS7. If you wanted to actually dump out, we can do that here, the default configuration that comes with IIS7 for the request filtering module. You can just issue this command, and it should dump the configuration out for us here. And we'll go over this in a second, but as I said before, all of the configuration now is text-based. So essentially what this is doing is it's basically dumping out the portion of the web server configuration that applies to the request filtering module. And I'll just run through, before we go through the actual file, just to give you some background on the different options it's got. This is just a quick summary. The first thing it'll allow you to do is prevent double encoded requests, and also high bit character requests as well. I believe both of these are the double encoded requests are not permitted by default. The high bit characters are permitted by default. It'll allow you to also restrict file extensions by type. So you can specifically say, I want only these file extensions to be allowed, or I want all file extensions except these to be served. As far as request limits go, it does some maximum tolerable levels for content length, URL length, and query string length. It'll also allow you to control the verbs that are issued, so you can restrict things like put, options, that type of thing, only allow get and post. And then it's got the deny URL sequences, which unfortunately doesn't support regular expressions. So those of you that use IIS and you had to maybe toy around with URL scan when the Asprox and the other SQL injection worms came out, one of the things that a lot of people realized is that while it does support looking at query strings now, which is a great improvement over the previous version, the newest URL scan they came out with, it doesn't allow you to do regexes. So you need to have an exact string that you're rejecting, which is somewhat difficult when you're talking about attack strings. And then the last option that it gives you is what they call hidden segments, which are basically just pieces, virtual directories within the root that are not going to be permitted to for external users to request. So you can still have content in them, like the bin directory is a good example of that, where you can't issue any requests, get requests to it, but there is executable content in there that the web server can run. So going back to the dump that we just did, you'll see that the default, and this is just the default configuration that IIS will install with, it basically does not allow, it allows any file extension to be served, so the allow unlisted is true, and then it specifically forbids all of these well-known file extensions that we know typically IIS isn't going to want to serve up, like .config, .cs, and so forth. You can also see that the default hidden segments, again, there's no surprise there. It's got the web config in there, the bin directory, the appcode directory. So these are all things that basically just comes pre-configured for a typical .NET app, but it is good to know that you can configure this and fine-tune this if you have another application or other custom needs that you want to restrict it for. So the better solution for a lot of the security related stuff, or I should say the more flexible solution, lies in some of these other modules that the Microsoft team has released. So as I mentioned before, since IIS7 first came out, and I think this is going to continue to be the trend, the IIS team is now working on a series of just add-on modules that they release for free on IIS.net. So these modules do a bunch of different things. Most of them are not securely related, but there are a handful of them that do have potential security uses. Some of them are specifically intended for security. Other ones you can sort of just be creative and come up with ways to use them for security. So we'll run through a couple of those right now. Specifically, I want to talk about the dynamic IP restrictions module, the URL rewrite module, and the application request routing module. And again, these are written by Microsoft, and they're free to install on IIS and download. So the first one is the dynamic IP restrictions extension. And essentially what it allows you to do is, in IIS you've always been able to block by IP address. What this allows you to do is define intolerable or tolerable, depending on how you want to do it, thresholds, and then reject users if they violate those rules. So the specific attack here is some type of a denial of service attack that you want to prevent against. So you can define a maximum number of concurrent requests or a maximum threshold of a number of requests over a period of time. And if anybody exceeds that, either you can block them by domain name or by IP address. It'll automatically update the IIS config to block them for a specified period of time. So we'll just take a quick look at that, and I've got that module installed here just to show you what it looks like. The IIS7 interface is again completely redesigned. The management interface, you can't even manage an IIS6 or previous machine from this console. So they've got the legacy console that comes with the new Windows, as well as the new one, which is meant just for managing IIS7 installs. But if you go to any of the websites, you basically have a bunch of options here, and I've installed the dynamic IP address and domain restrictions module, so I've got that option here. And when I click on it, there's a option to edit the feature settings. So by default, we'll say we want to allow all clients, and then we're going to go ahead and edit our dynamic restriction rules. And the resolution's kind of small here, so I apologize, but essentially we can say we want to deny IP address based on the number of concurrent requests, or we can deny them based on the number of requests over a period of time. So what I've done here is I've defined a policy that says if somebody issues more than 240 requests within a 60-second time period, let's block them for 1 minute. So specifically what I'm trying to do, and you can see the action down here, you can return a forbidden and not found. I'm just going to go ahead and abort the connection and close it. So what we're trying to do here is really thwart some type of a CGI or a application scan that's usually going to issue at least 4 requests a second, if not more. You can even lower this realistically to 1 request every second for a minute, and that's probably more than anyone's normally going to issue. So just to sort of demo this, let me go into, we've got Nikto, which is a CGI scanner. So I'm going to go ahead and launch a Nikto scan against and just to show you here before we get started, this is the Battle blog, which is the name of that ASP application. This is the default site that we're going to be working with. So I've got a virtual host here, www.battleblog.test. And oops. So you can see the site works normally. I'm going to go ahead and launch a scan against the site. So you can see it's already detected the server. It's coming back and letting me know that there's some methods that are allowed. It's warning me about cross-site tracing. It's also telling me that there's an X powered by header. And the scan has completed. So what we can do here now is if I go over to my show blocked IP addresses list, the local host is now on this list because we just violated that threshold, and Nikto probably didn't realize it, but about midway, if not sooner, through the scan, we got blocked. So if I were to actually just rerun the exact same scan right now, you'll see that it actually comes back and says no web server found on localhost, and that's because the server is just denying our request. And I can even go here and try and refresh the page, and I've got burp running because we're going to do some demos later with burp, but you can see it's giving me a timeout communicating with the server, and that's because the server basically just shut down the connection when I tried to connect to it. So as you can see, it's pretty useful for slowing down or thwarting some automated attacks against the application. Certainly, this isn't something we want to rely on as far as being like our only defense, but making the attacker's life a little more difficult to slow down these scans is always a good thing. So we'll go ahead and remove or add this to our allow list now, and we should be then allowed back into the site. So that's just a quick example or demo for that module. And that's pretty much all it does. It's a pretty simple module, but it's pretty nice functionality. The next one I want to talk about is the URL rewriter for IIS7. And this is a really cool one that it's amazing it took this long for for Microsoft to even come out with this. But essentially, this is mod rewrite for IIS. There's been a mod rewrite for IIS for years now that's an ISAPI module that is a commercial product. I think there's a freeware version of it. But Microsoft finally built their own, and this allows you to do pretty much the same type of stuff you can do with mod rewrite on Apache. So again, it's called on begin request because it's one of the first hooks that we want to make on a given request. And unlike the URL filtering or request filtering module, the rewrite module actually does support regular expressions and also allows us to access the different server variables. So it's going to allow us to do some much more flexible stuff than the request filtering module. And again, the intention here is not for security, but I'm going to show you how you can sort of write some rewrite rules that will allow you to enforce certain security, at least over GET requests. Now, the caveat here is that the rewrite module only applies to GET requests. It only looks at the query string and the URI, so it's not going to, I shouldn't say it only applies to GET requests. It only looks at the query string and the URI. It's not going to look at post data. So if we're worried about post level attacks, there's not much we can do with this, but we can certainly block access to certain URLs and even do some rudimentary, some basic query string validation, as we'll see here in a second, using this module. So going back to the sample application here in our management console, I've got another icon for the URL rewrite module here. And I've got two requests, two rules already defined that are just disabled right now that I'll enable real quick. But before we do that, I'll just point out a vulnerability here within the sample application. And that is that if we go to the comment page, which is comment.asp, we'll see there's an entry equals 6 in the query string. And as you can imagine, you stick a single quote in here, and we get an ugly database error. So this is a clear SQL injection vulnerability where they're not validating that input parameter. So what we want to do is we want to go ahead and try and figure out if there's some rewrite rules we can use to prevent this type of attack. So if I go into the first rule here that I've already defined, I called it drop invalid comment request. Essentially, what it's going to do is the first thing you do is you match a URL pattern, and you can do this as just a static URL or a regular expression. I don't really need a regex here, but we're using it anyways. And my pattern is simply just the name of the file, comment.asp. So what's going to happen here is this rule is going to match when the URI is equal to or contains the string comment.asp. I'm going to ignore the case, and then depending on, I've got some match conditions that I define here, and depending on whether they match or whether they don't match, I can then perform some actions. So I'm going to say match any, which means, and I've only got one, so it doesn't really matter. You can do match all or match any. We'll see that a little bit later where it comes into play. But I'm going to say if the query string server variables, anything in brackets here, relates to a server variable, and you can see here on the, just for reference, I've got the reference page for the module set up here. These are all the different server variables that you can actually reference from within a rewrite rule. So again, if you're familiar with mod rewrite on Apache, it's very similar. You can look at basically any part of the request to make your rule. And what we're going to do here is I'm going to say if it does not match the following pattern, my action is going to be abort the request or deny the connection. And my pattern is simply entry equals and then a numeric value, and you can see I've got it anchored on both sides there. So if the query, this is a page, and again, this all just comes down to knowing what our application is supposed to expect. This comment.asp page always has to be called with an entry parameter here. So if I call it with a blank one, you can see I just get another database error that's not necessarily because of my bad input, it's just missing a value. But So what my rule has done here is it's basically going to say if it doesn't match entry equals with a number, abort the request. So I'm going to go back and enable this. And I'll refresh. You can see that it still works. And now if I put in a single quote here, you can see I get the same type of response that I got before, which is that the server's just closing down the connection. And it doesn't have to be a single quote. Basically, anything other than a number in here is going to cause the request to fail. However, if I do pass a number in, it's going to allow the request through. Now, again, this only works because it's in the query string. If this page supports this same parameter going over a post, this rule may not apply. Well, it actually would apply because I defined it where it needs to have this query string value. But typically speaking, you're not going to use these rewrite rules to validate pages that accept data over a post, as I'd mentioned before. The other thing we've got in here is that if we go to the web root of this application, and I should have a window here that's already pulled up, you can see there's a bunch of stuff. There's like a test.asp page, for example, in here. And let's just see what that does. Essentially, that just redirects us back to display.asp, but you can see if I request that here, it's basically just a link back to the display page. So this is a test page. Doesn't really do much, but in general, one of the big problems you'll typically have is that there's garbage in the web root that developers leave over time that ultimately can get called by a user, potentially creating a security issue. So another thing we can do with the rewrite rules is we can basically just create a rule that has a list of the files that we do know users are supposed to call, and if the request doesn't match one of those files, send either, again, forbidden error or close down the connection or what have you. So what I've done here is basically just ran through, and I said there's a couple ways we can do this. I can say if the URI matches and specifically specify the pattern for the URI, which is what I've done with the comment page, or I can even just say if I can reference the request file name variable, which is going to be the full local path to the file name. Really just two different ways of doing the same thing. And again, because these are regular expressions, I don't have to write one for every single file. I can just do this approach here, which basically says if it's not article, ballot process, ballot send, comment, comment preview, display, index, preview, vote. If it's not on this list of ASP files, my default action is going to be abort request. And of course, there's more than just ASP pages here, so I allowed images, so any GIF file within the images folder, and then there's a CSS file we've got under admin custom. So basically, if the request doesn't match any of these rules, and that's why I've got the, this should be match any, it's going to fail the request. So if we go back to our application here, let me click on the comment page. That still works. And then now let's try and request test.asp. Just refresh. And it's still working. So let's go back and see what happened here. I think I forgot to enable the rule. That's what happened. So we've got the rule. Let me just select enable rule. And now that should be enabled. And you can see that my request to test.asp does not work. And it looks like this rule broke as well. Let me just disable this. I just wrote these rules this morning, so it's still in test mode. Well, there's clearly a problem with the rule here. As I said before, whenever you do demos, whatever can go wrong will go wrong. So we won't spend too much time matching. Oh, here it is. It's still matching on any. It should have been match all. So essentially what's going to happen is if it doesn't match any of these, which means it matches all of does not match, does not match, does not match, it's going to then forbid the request. So let me just reapply that here. So we can see it's working. And if I go back to the test page, that one's getting forbidden. So essentially anything that's not on our whitelist of authorized URLs is going to be restricted. So those are just two basic examples of how you can use the rewrite module for security. Again, not really the granularity that we'd want or need, but certainly for certain situations, certain scenarios, could come in handy. So that's the demo we just did. The interesting thing is if you compare this module to the request filter module, I mentioned before that the rewrite module has a lot of cool features and capabilities that the request filtering module doesn't. But by that same token, you can see that the request filtering module does a lot of stuff that the rewrite module can't. There's really, other than being able to check for the HTTP verbs, they each do things that the other does not. And the other thing is, with the first item there, scanning the URL path, clearly the regex capabilities is better than the substring that request filtering has. But as far as checking max length of the query string or the content length and so forth, that's something that you're only going to be able to do with request filtering. So certainly there's good use for both of these here. And there's just a little footnote there that there's another module, the IP restriction module that we talked about, that can be used to block IP addresses. You can also do that with rewrite. So the final Microsoft module that I want to talk about is the application request routing module. Again, this is basically mod proxy for IIS7. So what this allows you to do is create a reverse proxy with IIS7, and you can then start doing cool stuff like filtering any URLs or bolting using .NET authentication, anything like that, based on your different URL rules. So it allows you to basically now use IIS7 to protect another application that may be running on some custom web server or who knows, internally, or even just on a different IIS box internally, and you want to create some type of an application gateway. So this can certainly be a good thing for security, and can also just be a cool thing functionality-wise, allowing you to then publish internal apps through a reverse proxy. And again, it just supports load balancing, client affinity, that type of stuff. So the really cool stuff that you can do with IIS7, in addition to all the new modules, is you can write your own module. And the beautiful thing about that is that there's no limit to what you can do. So the concept, as I mentioned before, of ASP.NET modules is not new. It's been around for a while now. The difference here is that our modules can now intercept and handle requests for any content on IIS7. And an ASP.NET module is basically just a .NET class that implements the iHTTP module interface. You can write it in any managed language you want. You can also write these modules, as I mentioned before, which is what most of the ones that come with the web server are, in C++. But certainly most of them that are already out there, because people have been writing these for years, are written in .NET. So the inspiration for a lot of the features, or basically just doing all of this stuff with a module here, came from an article that was in MSDN back in 2007. Mike Volodarsky, who's the program manager for the IIS7 team, and I believe even also the ASP.NET, or at least the team within ASP.NET that handles the request pipeline, he always is coming out with cool stuff that you can do, and basically just showcasing all the different stuff you can do with IIS7. So what he did was he wrote an article where he took a PHP application called QDig, which is just an open source gallery type module, and he basically bolted on a lot of additional functionality and features to it, enhanced it using a managed module and leveraging the IIS7 pipeline. So what he did was he added authentication using .NET Forms authentication. So he wrote his own custom login page, defined all the authentication roles and permissions within the web config. And because now all of those permissions apply to, or all those, the request filters apply to PHP or any other app as well, he was able to enforce role-based authentication on his gallery. He also did some cool search engine-friendly URL rewriting. And the nice thing is, not only was he rewriting the requests inbound, which has been done for a while now, but he also was transforming the requests on the way out as well. So the PHP app was actually writing the old clunky query string URLs. He was actually on the fly, as they were being generated out, rewriting them to match the search engine-friendly patterns that he had defined. And then the other thing he did was he added output caching to speed up performance. So he used the ASP.NET output cache to start caching images that were being served by these PHP pages. So he did a lot of cool stuff, and it got me thinking, you know, there's a lot of stuff from an application security perspective that you could do, you know, aside from authentication, that is really perfect for this type of scenario. So I was talking with some folks, and we had the idea for building this application security module for IIS7. And the idea was that if we had access to all these different events, we could parse the request, we could parse the response, we could keep track of all the data that's going in and out. So not only could we do some data validation like known bad signatures that most of your WAFs out there already do and just kind of a blacklist, we could also do a little more intelligent authorization level defense mechanism because we know what the application is presenting to the user. And in theory, the user shouldn't, unless there's a login page, an entry point, the user should only be following links and forms and so forth that the application renders. So our thought was, let's leverage response analysis using a module to figure out what the user should be able to do and only let them do that. So the concept is pretty simple in theory. We basically look at every response and say, okay, what options is the application presenting to the user? And if the option is not on the page, then let's not let the user access it. Typically, the application's only going to present users with links to stuff they should be able to do. As we all know from a security perspective, it's very common that you have hidden links and security through obscurity that allows you to do stuff you shouldn't be able to do. So the goal here was to try and prevent that type of scenario from occurring. So the end product of that was what we ended up calling Secure Parameter Filter, or SPF, for IIS7. And essentially, the nice thing is it's not just for IIS7. It works on IIS6 as well. The difference is on IIS6, it only works on .NET applications versus on IIS7, it works on across the board. And essentially what the goal is, it tries to prevent non-editable data, so pre-populated form inputs like hidden fields, drop-down lists, etc., from being manipulated by the user. And it also tries to figure out or prevent the user from accessing resources they haven't been specifically linked to. And the way it does that, as we'll walk through here in a second, is a combination of output tracking and output response parsing, as well as request validation on the way back in. This is a free module. It's actually available for download on the URL up there on our website. So feel free to download it and play around with it. And essentially it has two main pieces. And a lot of this inspiration also came from another project out there that's been around for a couple years called HDiv. Is anybody familiar with HDiv or heard of HDiv at all? So HDiv essentially is a Java filter. It's a set of custom tag libs that work with struts and Spring. And what it does is essentially it tries to do the same exact thing we're doing here, where they override all the tag libs so that every form input, every link that gets rendered out, they add a token to it. And that token is tied directly to the user for which it was rendered. So without a token, you can't access any resource. And a user can only access resources with tokens that they've been provided. And those tokens are actually tied to every resource. So I'll go through that. It'll become a little more evident what I'm talking about here because we pretty much try and do the same thing with this module. But the way it works is there's a response filter, and that analyzes the HTML on the way out, and it looks for URLs, any form data, cookies, and then JavaScript functions as well. And we'll talk about why it's looking at JavaScript later on. And what it tries to do is figure out for every single form what the state of the form is. So what are the inputs associated with that form, and what state are they in? Are they editable? Are they read-only? Are they hidden, in which case they're pretty much read-only? And then what it does is it tries to then, it correlates that back to the user that requested the response with a token value, and those inputs are only going to be allowed back in along with that token, provided that it's the same user. So the request filter essentially does that. It looks at every request and figures out, is this authorized based on the tokens or unique IDs that it issues on the way out. And the only thing that you can get to without a token, because you need to start somewhere, is the entry point, which is typically the default landing page or the login page for the application. And as a catch-all, it also has a blacklist that applies to post, get, cookies, all that stuff, depending on how you configure it, just to as a catch-all, because these tokens are only going to prevent, like I said before, the non-editable inputs. So a free-form text box that says, please enter your comment here, there's no way for the module to know what type of data is going to be in there. So for that scenario, you've got a blacklist that you can define some known bad patterns. So going back to the pipeline, there's 3 specific events that we're hooking into. The first is the begin request event, which is for validating the request. And then on the way out, we're going to look at we're going to parse the response on the released request state event. By then, the handler has already generated all the HTML. And then we're going to also look at the request on the end request to make sure nothing's happened between released request state and end request. Specifically, there's sometimes cookies that are added between there by the .NET framework. So we do all of our cookie parsing on end request. So the module itself is very easy to install. It's like any other module. And something I did sort of skip over before that I'll just cover real quick here is I mentioned before all of the configuration in IIS7 has been moved into .config files. So the web.config for the BattleBlog ASP site, as you can see here, has our rewrite rules in here. So the nice thing is that any of the modules that you want to configure, all the web server settings, you can do that in your config file, and as a developer, you can push that out with your app. You don't need to have access like you did before to the IIS7 management console or IIS6 management console to lock down what types of files are served and so forth. It's all done via config. So as a developer, it's going to give you a lot more control over the web server configuration when your app gets pushed out. Now, clearly there are ways for the global machine config to override your settings and so forth, so this isn't necessarily foolproof, but you do have the option of at least surrendering, or administrators have the option of surrendering that level of control to the developers. So going back to the modules are all pretty easy to install. Essentially, there's a module section within a web.config, and you just basically define the name of the module. So we've added our IIS.SPF.core module as the type. The name of it is ISPF. And we're just adding one here. So whatever modules were already configured at the server level, we're just adding one. We could easily remove other ones here. We could re-specify all the modules, but we're just going to add one. And notice here that I'm just going to say run all managed modules for all requests. And that's basically what's going to allow my managed module, which is written in .NET code, to apply to unmanaged requests like ASP, for example, or PHP. So all you got to do is add the module. Then we've got a custom configuration section for the module that really just defines the different configuration settings that the module needs to operate. And there's just some very basic settings that we need to put in here. Specifically, there's a log file directory, and then you just have to tell it what you want to protect. So we're going to say protect form. There's basically just got to specify form, values, form state, query string, cookies. We'll get into all this stuff as we go on. But basically, I've set everything to true, and I've said that only protect ASP files. So once we've done that, the module pretty much is running. And the first demo that we're going to do is, failure to restrict URL access. So as I mentioned before, the BattleBlog application has a bunch of flaws in it. One of them is that it's got an admin upload page that's just sitting behind the admin folder that's not linked from anywhere. Once you're authenticated as an admin, they give you a link to it. And if you know it's back there, you can call it anonymously. So just to demo that real quick, if we go back to, let me just make sure our rule was removed that prevents me from requesting anything on our whitelist, otherwise this won't work. So the first thing I'm going to do is show you the actual page. It's basically called uploadform.asp. You can see I'm not logged in as an admin, and all you've got to do here, as you would imagine, is browse for a local file, and it'll go ahead and you can upload anything to the uploads folder. It's a pretty bad vulnerability, especially considering you can upload ASP files and start executing them. So what we want to do is we want to prevent somebody from finding this page and linking to it. So if we go, we've got another virtual host running another instance of the BattleBlog application that's called spf.battleblog.test up there in the URL. And essentially, that instance is protected with SPF. So I can see here that when I go to the administration page, for example, or any page, I've got a URL token in the query string here. And essentially what that URL token is if I've got a slide that sort of outlines what's happening here. There's a cryptographic token that's appended to every single request that gets generated by the app. And the reason for that is it's going to verify if there's any query string values in there. It'll make sure that those haven't been tampered with. And it'll also make sure that I'm authorized to access the URL itself. So the way it works is if we've got the application on the right and it's going to generate links to the user, it generates a link, let's say, to showarticles.aspx, and it's got an article ID in there. So what SPF is going to do is it's going to say, okay, I'm going to add a URL token to the end of that link, and that URL token essentially includes two pieces. The first is a timestamp, so we can configure a timeout for any link. So if the link goes stale, the user's not going to be able to click on it. And then the last piece is basically just a SHA-1 HMAC of the following pieces of data: the URL, the query string, the timestamp, so we make sure they didn't edit the timestamp. And then every time there's a new request issued to SPF, it'll send you a session cookie that's almost like a session ID. That's just a random GUID that it generates. And that cookie is also included when it calculates this SHA-1 HMAC along with your source IP address. So when the request comes back in, SPF is going to say, okay, you're asking for this page, let me pull your token, and let me recalculate the HMAC. If it fails, it's not going to let you in. And there's really no way for someone to figure out what this HMAC is going to be unless they have access to not only the machine key, which is the ASP.NET machine key that we're using to generate the HMAC, and all of these different values. So practically speaking, if the app isn't rendering you a link to a page, there's really no way for you to request it. So as we can see here, anything that the app links me to, like the comment page, for example, my URL token is there. If I take the URL token out, I'm going to get a forbidden error, and this is we've got detailed errors turned on here. So you can see here that I've got an invalid parameter name of entry, and that's because there's no token on there, so it's immediately failing the validation step. So if I try to access the admin page that we had just seen a few minutes ago, which was upload form, I believe. Let's do admin. Same thing, missing token. So there's really no way for me to get to anything that the app doesn't specifically link me to. So this is going to prevent not only query string manipulation, but also just forced browsing attacks, as we see here. So after the SPF module has rewritten that link, it's going to send it back out to the user, and on the way back in, it's going to validate it, as we saw. Now, the nice thing is that there's an added bonus where we also get some cross-site request forgery protection here as well, because if I don't have that token, again, is tied directly to a cookie that's issued to me. So somebody can't force me to make a request to any page unless they have the right token. And unless they have access to my session cookie, there's no way for them to calculate that as well. So the nice thing is if we do have CSRF attacks, and we do have one here, I'm not going to demo it, but the add user form isn't tokenized whatsoever if you're an admin. There's no way for us to be vulnerable to cross-site request forgery because an attacker is not going to have access to that cryptographic token. And again, the key part here is that even if they have an authenticated session, their session cookie is going to be different than my session cookie. So there's no way that they're going to be able to convince the server to issue them a token that's going to be accepted for me. Does that make sense? So I mentioned before there's several other vulnerabilities here. The next one is SQL injection that we already saw in the query string, but specifically that issue is also exploitable via post request as well. And the way SPF protects forms is a little bit different. It has two methods of form protection. The first is form state, which records the different inputs that are associated with a form, as well as whether they're editable or not. And then the other protection is the value itself. So we have the option of masking values, hidden values, so that the user can't see them. And when we talk about editable versus non-editable, we're talking about things like hidden fields, radio boxes, check boxes, etc., which are typically read-only. So just to give you an example of how that would work, let's say we have this form here. It posts to the search page, and then it's got a text input box and then a bunch of other what we'll consider non-editable inputs. So what SPF is going to do is it's going to record form state information for this form. Specifically, that's going to include the action, so where the form posts to, The owner, which is going to be that session cookie that I talked about earlier. So we always have a session cookie once we're talking to the server. It's going to record me as being the owner of this form. It's then going to assign a unique form identifier to the form. And again, that's just another GUID. And it's going to insert this as an extra hidden field in the form. And then it's going to run through and actually record all the different non-editable, or all the different inputs, and say whether they're editable or not. So we can see that the query input is editable, so we don't have a value for it. And on the way back in, we're going to allow anything through there as long as it's an input name of query. And then for the other ones, we're only going to allow, since they're non-editable, the values that were pre-populated in there. And I mentioned before that it not only has the ability to prevent you from altering it, but also prevents us from seeing them as well. So you can see that it's going to replace on the way out the different values with essentially just the array position within their respective arrays of that value. So there's only one value for all of those items except for scope, which has 2. So you can see there's 2 scope items, a 1 and a 2. So let's go ahead and see how that looks when we actually access the application. I mentioned before, this is the request, this is the version that's not protected. So if I go to, let's say I want to go to the politics category. I'm going to use burp to intercept this since it's a post request and you're not going to be able to see it easily. So when I go and make the post request, you can see there's 2 inputs. There's a category equals general and an order equals comments. So if I stick a single quote, for example, in one of those, and I forward on the request, it's actually going to generate a SQL Server error down here, which indicates that that value is vulnerable to SQL injection. So if we actually contrast that now to the version that is protected with SPF, let me forward that response on, and I'll go to the SPF version of this page, and I'll just forward this request. So I'll do the same thing. I'll say let's sort by score and politics, and I hit the go button. This request is much different. You can see now I've got the form token, which again references that form state information that's stored on the server, and then I've got category equals 3 and order equals 2. So there's a few interesting things here. The first is that because I recorded that form state and there's only 2 possible inputs, I can't add a third value called, and foo equals bar, because that input was not included on the original form. So it's not going to be in the form state that's associated with that token. The other thing is I can only substitute valid values here that correspond to values that were recorded on the way out. So I really have no way of manipulating or editing these values other than to other values that were originally presented to me. So even if I change this to 5, which I don't think there were 5 order values there, you can see that I got rejected and it says missing token order, and that's because that value was not was basically manipulated and it wasn't found in the lookup table on the way back in. So what SPF is doing is it's just taking the exact same substitution that we did on the way out. It's just undoing it on the way back in. So from the application's perspective, once it does go through, if I actually just reissue that exact same request and I don't change anything, you can see that it works. And it says now lets me know I'm in filtered mode. There's nothing under politics. So we can do like general. And you can see that, so to the underlying application, nothing's been changed in the ASP code. It doesn't even know that this substitution occurred. It's all happening on the fly as the data is going out, and then it's all being undone on the fly on the way back in. So another nice thing that comes along with the fact that we're substituting these values on the way back out is that we're protecting them from being disclosed to the user. So another silly thing that this app does, and again, this is just a great app for doing these demos because this is all just stuff that's built right into it, is when you go to make a comment, they've actually got a CAPTCHA. Let me turn intercept off. And if I go to generate a comment, you'll see that there's a CAPTCHA that says, please type in the word, what have you. And if I actually do a view source, there's a hidden input called security word with the actual value of the security word. So this is clearly going to be an ineffective capture mechanism because any bot that's trying to spam this thing is going to have access to the value itself. So this is really just a silly thing that the app is doing. If we actually take a look at the version that's protected with SPF, because it's masking, because it's substituting all those inputs on the way out, the same page, if I go to view source and I look for security word, security word equals 1. And again, that's because the data itself is being stored in the form state and not being sent out to the user. So it also prevents the user from viewing this data, which in this type of scenario is very valuable. The other nice thing as a side benefit is that it also reduces, if we think about view state, for example, view state is huge and oftentimes can be, it can even start impacting performance because it's a huge amount of data, even doubling the size of the requests going in and out. This same concept can be used to store the view state on the server as well. So it'll just say view state equals 1, and it'll even decrease the level of bandwidth that you need to do your requests and responses. So there's some nice non-security benefits that you have here as well. Now the final thing I want to talk about with SPF is the JavaScript protection. And this is something that originally we hadn't even thought of, and this is something that actually HDiv doesn't do. But we quickly realized the need to do it. And that is that these days, every application uses JavaScript, and it's very often that JavaScript functions are actually used to send data in and out of, or basically issue requests to the server. So there's a few variants that this can take on. And this is really even just basic JavaScript. We're not even talking about intense AJAX stuff here. The first is if you want to just do a link, instead of doing an href, you can just have a JavaScript function that when you click on it does a window.location or a location.href. So SPF automatically treats, anytime it finds a call to window.location or location.href, it treats the value that's being passed in as a URL. So it's going to protect that the same way it would protect an ahref tag. The more interesting one, though, is for JavaScript functions that actually are used to generate a request to the server. Specifically, the one that comes to mind in the .NET world that you can't get away from is the doPostback function. So let's take a quick look at how we can handle this situation. Essentially, the JavaScript function doPostback, which is a standard .NET function that's in every application, takes in two values, the event target and the event argument. And those two values that are passed in when you click on a link that calls doPostback, essentially it takes those two values, assigns them to those two form inputs. So the form has an input called _event target and _event argument. It'll populate those two hidden inputs with that value and submit the form. So this causes a problem for the way we're doing things in SPF because on the way out, those hidden inputs had no value. So on the way back in, they're coming back in with a value that was assigned via JavaScript that we didn't know about because it wasn't even in the form block. So to compensate for this, we figured out, okay, what do we need to know about here in order to make this work? So specifically, if we can identify what the function name is that's doing this, the different arguments to that function and whether they're actually going to be used as a form input or not, and then where they're being assigned, then we can easily figure out a way to allow those values back in when we're parsing that response. So what we do is we have and this is the one thing, everything else that I've described so far does not require any customization. It's all done on the fly. This is the one thing that you'll have to configure if you're using JavaScript to perform requests, because there's no way that again, barring us building some type of a JavaScript interpreter, there's no way for us to know what functions are doing this. So what we've done is we've defined a manual configuration entry called script protection that basically just says, okay, give me the function name and give me all the arguments to that function and just tell me whether or not to protect them. And if I do need to protect them, tell me whether the name of the input that it's going to be assigned to. You don't need to have the name of the input that it's assigned to, but as we'll see in a minute, it makes it a little more secure if you can do that. And essentially what we're going to do is we parse this data on the way out, and we protect these values. Rather than using the substitution mechanism like we used before, we actually just encrypt them, and we decrypt them on the way back out. So let's use an example here. We know, as we mentioned here, we know that there's going to be a function called doPostBack with 2 inputs, and the first is going to be assigned to the event target input. The second is going to be defined to the event argument input. So here's the actual JavaScript function call. We're going to go ahead and transform that to this, which looks like gibberish. But essentially what this is we'll just use, you can see there's actually there's 2 arguments here. We're just going to look at the second one, but essentially the same thing happened. The very similar process was used to protect the first one. So the input is just 3 pieces of data that are all separated by a colon. So each argument value has been separated or has been replaced with these 3 inputs that are colon delimited. And the first is just a base 64 encoded representation of the encrypted input value. And we encrypt it with the default ASP.NET Machine key as well. We don't want to have to worry about key management. And we also include some random 8 bytes at the beginning of it that are sort of like a pseudo IV, just so that every single input encrypts to something unique. The second piece of data is a timestamp. Again, we don't want these things to be valid forever, just like the links, so we expire them after a predetermined set of time. You can always set this to 0, in which case it'll never expire. And then, just like on the links, we generate a token. And that token covers the integrity of the ciphertext to make sure no one messed with it, the timestamp to make sure it hasn't been altered, and then we tie that to the session cookie, which is that GUID, the source IP address, and then optionally, the input name and the target URL if we have that information. So we do have the input name here, which is event target and event argument. And the reason we do that is we want to prevent somebody from taking these 2 values and swapping them out, so that even if they can't directly manipulate one or the other, they can take the value from one and place it into the value of the other. So by including the input name within the HMAC, we basically bind that token to that input name, so you can't do substitution. We're running out of time. I did have a demo of that on a .NET app, but we don't have time for that. I will say, not only is this app available for download, we have a public site that runs an application called .NET Stock Trader, which is an MSDN sample app, and we've got 2 instances of it running, one that is protected with SPF, one that is not. So you can actually toy around with it live on our test site if you want to sort of play with it and see it in action. But briefly, as I mentioned before, the configuration options here are minimal. It sort of takes the same approach as the allow and deny stuff on the .NET settings, which is you define the default, which is, say, protect everything. And then if there are certain exceptions you need to make, so maybe there's one page that is doing something so convoluted that we can't possibly figure out a way for SPF to protect